6.4 is transformations of trigonometric functions. So we're going to do sine and cosine. It's all sine and cosine. We aren't doing transformations of tan or cotangent or cosecant or anything like that. We're just back to sine and cosine. Right? So we're doing transformations of sine and cosine. So we've got that here, sine and cosine. Okay. Now let's go through, thank you. Let's go through a few of these things here and remembering our words. We have all the same. We have all this. Sorry, is that okay? All right. We have all the same words as before. So amplitude is our vertical stretch or compression. Right? You have to know both ways of describing it. You can describe it in terms of vertical stretch or compression or amplitude. Both of them are good ways to describe it. So you have to know both. A vertical reflection is just a vertical reflection. There's no different way to describe that one. Horizontal reflection is a horizontal reflection. Period is a new way to do it, to describe it when we're talking about trig functions. So amplitude and period are specific words that we use when we're talking about trig functions. The other words are all the words that we use with every other function as well. Okay, but the two different ones are these two, amplitude and period. When we look at this, we can break it down in terms of the equation. So when I look at this, I know that the amplitude is going to be this part here, so this will be the A value. That's the A value here in front, the amplitude. Okay. The vertical reflection is if A is negative. Does that make sense? If the A is negative. All right. Horizontal reflection will always be from this part here. So horizontal, everything horizontal, right? This horizontal part is going to come from this part of the equation. This part of the equation. So the horizontal always comes from this part of the equation. The horizontal reflection will be if the K is negative. So if the K is negative. Okay, if the K is negative. Now, what else do we want to know? We want to know that for the period, this K value here, the K must always be factored out from the horizontal translation. So this part here must be in factored form if there's a D. Okay? If there is a D value there, we must common factor out the K. If there's no D value, that's okay, because it would just be KX. That would be fine. But if there's a D value, it has to be factored out from the D. What we want is that we don't want the horizontal stretch or compression affecting the translation. They're two separate statements. You're moving it left or right, and you're stretching it. So you stretch it first, or shrink it, compression, and then you're shifting it. We don't want this affecting this, right? So that's why we have to factor it out, so it must be in factored form. So we're going to say, over here, for the period, that's part of the horizontal stretch or compression. This K value will get me the period. So this, we would say the period is going to equal 2 pi over K. We used to, last year, we would say that the period was equal to 360 over K. That was last year, right? So that's what we did last year. But now we're bringing it to radians. So 2 pi over K, right? So same idea. So that is going to be the K value that we're trying to find. So we'll do that in a bit. The horizontal translation, also part here. So all this part here that's boxed off is from this part here in the equation. Does that make sense? So this box here, that's all the horizontal stuff. So the horizontal translation must, again, be in factored form. So remember to factor, right? So you have to factor the K from the D. Does that make sense? So you want the K away from the D. The K has to be separate from the D. And I said that down here. Factor to separate the argument from K and D. I did a typo, sorry. So I said the same statement here. Right, so factor to get the K and the D separate, and it should have been D, not C. Can you fix that in the notes, please? So it should be a D. Right, so make sure the K and the D are separate. You want that in factored form. And remember, it's also the opposite sign. So it's the opposite. Right, so if it's a minus D, you're moving to the right. If it's a plus D, you're moving to the left. And we've done that since before, right, the horizontal, so it's the opposite. Okay, so we'll just get to that in a minute. Sorry, yes?
So is like X and D and K in radians or degrees?
The only thing that's going to be in radians is going to be this, right? So this is going to be my shift up and down, yes, and my amplitude could be in whatever value it is, so it'll be 2, 5, whichever. But yes, so the K and the D is in radians, yeah. It's the horizontal.
The K and the D.
Well, the K doesn't really have a unit. K is a scale. K is your, I'm multiplying, I'm compressing it or stretching it. So K doesn't have a unit. K is without unit. We did that last year as well.
So just the D.
D is, yeah, but when we're finding the D, we're doing it in radians.
And the X.
Oh, the X, yeah, but the X is, yeah. Yeah, well, the whole function is in radians. The D is the only one that's going to need the radians. K has no units because K is the scale, like we're stretching it or compressing it. So yes, so the X and the D. Okay, yeah. Yeah.
But like in the word problems last year, sometimes we have to put a degree value on the K. Would we do that this year too?
Yes, so in order, yeah, so the reason why you got that is, and so when we get a K value, if it has a pi in it, it'll cancel out. So when we get a K value and say it's 2 pi, then I put it into the formula, which I'm going to do in a second. Where did I put it? Here, formula. 2 pi divided by 2 pi, that means my period is 1. And what does that mean about your period? Your period is 1. It could be 1 hour, 1 day, right? 1 meter, right? So it depends on what you're trying to do. So in order to get rid of the pi here, I would put a pi there. And that gets rid of it, so then my period is now 1. And remember, the period doesn't have to have a pi in it, right? It doesn't have to be, it can be 1 day, 1 cycle, 1 meter. Every 1 meter, it moves this many this. It could be meters to meters, right? Every 1 meter that moves forward, it's going up and down. So there's different scales and stuff. So yeah, so you can get, so but that's not because it's in radians, it's because we're using it to get to the period. Right, so I don't think of it. So K technically is not a unit, right? K is the scale of how much you're doing. Right, so you multiply by 2 pi to get to a period of. Right, so K technically has no scale on that one. All right, it's the multiplying factor. All right, good. Vertical translation is the last number. That's just the C. There's not much to say about that. It's up when it's up, it's down when it's down. So if it's a plus C, you're moving it up. If it's a minus C, it's moving down. Nothing fancy about the C. Okay, we got this. So from here, one more time, I want you to factor the 2 from the pi. When you factor it out, what are you doing? You're getting plus pi over 2. Does that make sense? Right, so to factor it out, you're dividing it by 2. So you're dividing it by whatever it is. It's actually really useful in fraction form. Because if I say it's pi, to factor out the 2, you divide by the 2. If it was pi over 2, I would make it pi over 4, so you're dividing it. So when you divide out, when you factor out, you're actually dividing. That makes sense? Okay, so I'm going to go pi over 2. Okay, so you want to do that. So let's go ahead and start to answer it. So we've got period, amplitude, equation of the axis. So period, amplitude, equation of the axis, and then I want you to state the transformation. So from here, this we're going to get from this period amplitude, which is the new stuff, kind of the trig stuff, and then I want you to state the transformations like vertical stretch, compression, all of this stuff like normal. So we're going to do 2 parts to this question, and then we're also going to graph it. So we're going to do kind of everything in this bit here. So the period amplitude, I'm going to do the amplitude. I always start with that. Amplitude is the 3. Right, whatever the number is in front. The period is always going to be 2 pi over the K. This 2 is not the period. This is K. This is K. That's your K value. It is not your period. That is K, not your period. It's supposed to be a lowercase k. I'm sorry, my K's are bad. Okay, so K. No one really cares too much about that. I'm trying to make my K's neater. I feel like they're messy. Better work on that one. Okay, so that's your K, okay? Put it into there, and you're going to get your period equals 2 pi divided by the 2, which gets me pi. So my period is pi, right? So my period is pi. Do you have to show me all that? No, you don't. If you just put your answer pi, that's okay. Okay, so just answer period is pi. What else I asked for? Equation of the axis. Make sure you give me equation. It's always, always equation. So the equation is going to be y equals -1. You have to have it, right, in equation form. So for my axis, the y equals. And make sure, yes, equation of, always equation. Okay, so that's one part of the question. So that part of the question was just asking me about this. I also want you to state the transformation. So we're going to state the transformations as well. So but that's one part of the question. So I'm just going to put this over here. So that's one part. That was this part here. And then my transformation. So I'm going to state my transformations. For my transformations, I always go left to right. I want to make sure this is in factored form, though. So can I please factor this as well? So we're going to go 3 sine, I know I'm writing horizontally, but I'm just doing this for rough, so 2 bracket x plus, if I'm factoring out the 2, I just showed you up here, it's going to be 5 pi over, when you factor by 2, you're dividing by 2, so that makes it 6. Is that okay? -1. So when you factor out a 2, you're dividing it by 2, so it makes it 6. Okay. So from here, let's state all of our transformations. I always go left to right, making sure the translations are last, right? And that's just a habit we got from last year. So let's go ahead and I'm going to write these guys here. So it's going to be actually I'll go, so this one and this one, those are my verticals. So I'm going to go start with the first one. So vertical, actually I don't need to do this, right? We're grade 12. You know, it goes 1, 2, 3, 4. I used to number it, right? 1, 2, 3, 4. So vertical, and this will be a stretch by a factor of 3. That's the first one. Okay, the inside here, it's going to be a horizontal, right? Do you need me to number it, or we're okay? I used to number it in grade 11. 1, 2, 3, 4. Do you want me to number? Yes, no? You're okay, right? We're good for now. Okay, so horizontal, this would be compression by a factor of 1/2. We okay? Reciprocal. I'm going just faster just because we should know this from last year a little bit. And then here, because it's in factored form, that's good. So we're going to say it's going to be a horizontal, right, factored. It's going to be a translation, and that'll be left 5 pi over 6. All right? Okay, and then my last one here is this is going to be a vertical, and it's going to be a translation, and that'll be down 1. All right. Let's go ahead and graph it. Usually I give you a bit of a grid here. I didn't, just because I figure it's our notes. We'll do it together. Try to get somewhere kind of halfway-ish. My grids are awful because they're not balanced. Look, I have 6 and 5. I don't know why I didn't do 6 and 6 on the top. I don't know. It's misbalanced. So somewhere in the middle-ish, it fits. Okay, and then scale. We have to remember scale. So you have to label the scale. So I'm going to say label scale. If you don't label the scale, the units, so label the scale. If you don't label the scale on the graph, you're just getting no marks here. They all look the same. They're all sine and cosine. They all do the same shape. You can't be like, but I got the shape. They're all sine and cosine. They all have the same shape. Without the scale, they're all always going to look exactly the same, exactly the same, exactly the same. So you need to tell me what the scale is, because I can't. It could be sine, could be cosine. Who knows? So you have to label the axes, right? 1 unit along each one. You don't have to label every square, but something has to be labeled, because literally they're all sine and cosine. They all look identical. So I'm going to go by ones, along the vertical. I just need 1 unit. You can label more, at least 1. Don't do anything fancy, so don't go by halves or something or thirds unless you have to. So when I look at this, I can see it's a 3 and a 1. Don't do anything funny. If this was 30, I would go by tenths. So 10, 20, something like that. But if it's just 3 and 1, don't do anything fancy to your scale. You end up not reading your own scale. Okay, so if it's just 3s and 1s, I'm just going to go by 1s. Don't do anything extra. All right, so label your scale. X, I need to label at least 1 unit along the X. So label, so at least 1 on each axis. One label on each axis. Does that make sense? Right? If you label nothing, they all are sine and cosine. So label at least one label on each axis, right? So at least 1. Okay. So most people go, okay, 1, 2, 3, and they do 2 pi. Hang on to that for a second. If I know that the period is pi, do I have to show that it's 2 pi and then I shrank it? No, they all have the same shape. They all are going to look like a sine or a cosine graph. I don't need you to show me, hey, my original one was here, and then now my new one is, they all look identical. So if my original one is 2 pi, how would I just make my original graph? I do 3 squares, I don't know, makes it easier to graph. And I'm going to write pi. There you go, my period is done. The period is pi. That's pi. Instead of 2 pi long, I'm just going to draw it under pi. It's all the same shape. So when you get the answer at the back of a book and they graph it, they're not showing you what it was and that they scaled it down. Just give me 1 cycle, which is pi. So you don't have to show me 2 pi and then pi. Does that make sense? Right? It just adds another graph, and then you have to scale it twice, and right? So no, just pi. So whatever it is, try to get it so it fits there. So that's nice. My axis, I usually start with my axis. I find that's easier, so I go and draw my axis. You do not have to draw this. I do it for myself because it makes my drawing neater. You do not have to. You don't have to label it with the equation. I guess unless your teacher says so. I'm your teacher, so I'm saying no. So no, I don't need it, okay? I don't particularly. I think maybe some teachers say you must draw it. I say you don't. It's optional. You don't have to label the equation. I like to draw it, though, because then it makes my cycle nice, and then I can count easier, and I do my amplitude from there. Like, I find it very useful, so I do that. So from here, you can draw your original graph on this axis. So this is my new x-axis. You can draw your original graph on this doing your period at 2 pi. I don't need to see 2 pi, then 2 pi, then 1 pi. So let's just draw the graph. I know the amplitude is 3. I know the period is pi, and I know the axis is here. I'm going to do a separate graph to show this translation. See, I've covered everything. Right? So I've covered this. The compression is the 2 pi. The stretch is 3. And the translation. So all of these 3 are all done. The purple one is the only one I haven't done. So I'm going to do this in 2 graphs. One for this green one here, and then I'll do a separate one for here. If you can do it in 1 graph, go ahead. Okay, I don't need to see 2 different graphs. Yes, did I make a mistake?
Do you have to put the dotted line for the...
No, you don't have to. No. So one more time, you don't have to show me that at all. Yeah. I do it just because it helps me draw a neater graph. Okay, so this optional, you don't have to label the equation, you don't have to draw that. So this dotted line is not, you don't have to do it. You can draw 2 graphs or just 1. So one more time, I'm going to do 1, 2, 3 on 1 graph. So that means it's sine. Oh, please look to see if it's sine or cosine. It's such a wasted mark when you don't read your own thing. It's sine. So sine is this one. So we're going to start in the middle and head up. Okay, don't draw the cosine unless it says cosine. So it says sine, so I'm going to start here in the middle on my line, my new axis. Then from this axis, I do the amplitude of 3. So I go up 3, and I know it's here. 1, 2, 3 from my axis. And then from my axis, I come back down to it. So I do my tick marks on my axis, you see? There you go. And then here, 3 down from here, and then back to my axis. And I draw it like this. Isn't that beautiful? Okay, really pretty. I use that axis to help me balance. I look at it and make sure it's symmetrical.